Hello guys, in this video we'll learn async cross-platform development using Rust. Now this is the most important video of cross-platform development series using Rust on my YouTube channel. Be it any mobile app, web app or desktop application, we want our users to have a seamless experience while we make any network call or process any task which could potentially block our UI. We want our UI to be free so users can have a good experience while browsing through our website. For that, we need to understand and grasp the async programming concepts very well. So I would highly recommend you guys watch this video till the end and understand all the concepts. If you have any questions, feel free to leave in the comment, or you guys can join me on my Discord and literally raise any questions. I have the link in the description. So we'll start by understanding the problem. Why do we need async programming for cross-platform development using Rust? Then we'll talk about async and await and future. Later we'll discuss about spawn, use future and use coroutine. These are three major concepts of async cross-platform development using Dioxus and Rust. Now, I can guarantee if you understand these concepts, you can literally create any cross-platform app with an amazing user experience, as all the async programming that we do using Dioxus for cross-platform development in Rust is based on these three things, and we can literally solve all the challenges that we could face for asynchronous development using these three things: spawn, use future and use coroutine. In the later videos, we'll also talk about different hooks which are majorly based on these three concepts as well. So let's begin and let's understand. So first of all, move to the project explorer. Now I already created a template Dioxus project. So if you don't know how to create, consider watching my previous videos. I already explained you about Dioxus CLI, how to add a new project. I would highly recommend first watch those videos, should be popping somewhere on right top. Click it, watch it, and then move to this one. So let's move to main. Now here, first of all, we'll try to create that problem for which we need this async programming and all these stuff. And so let's create that problem. Let's block our UI and try to understand why do we need even all these things. So let's add a very basic example. We have an app, returns an element. We launch the app and here we have clicked state or signal and an RSX. So what we do here is a div, and then so we say if clicked, then we want to do something else, we want to do something else. So if it's clicked, then the style is color white and the text is operation in progress, UI is blocked. Let's print this, and then here we have a button, and on click we have a event handler. So let's add the handler separately so it's easier to understand. Move event we discard, and here what we do is we set clicked to true, and then to simulate the long running or a network call, we just sleep this thread for, let's say, 3 seconds. So you can say a heavy task. And finally what we do is we set click to false. So basically why we set this false and true is when it's true, basically when button is clicked, we want to show this, otherwise we want to show the button. So we'll use the handler here, and the button name will keep as start processing. Let's say it's a pretty simple UI that we have, and let's see. So open your terminal and move to your project and just do dx serve. It's up and running. So let's minimize and we go to our embedded browser and we go to localhost 8080. As you can see, our UI is here, and since initially we set it to false, so it goes to the other side and prints the button. So there we have button on our UI. We click the button and nothing happened. Basically, this operation blocks the UI from getting updated or changed. Now, how do we do this? Because this is one of the most common things that we do. We click a button. On click of the button, we make some call. For example, it's a chat application. When user press send, we want to send that message to the backend. Similarly, any other use case that you can think of, we click a button, we want to process something or call some API or do some processing, which could potentially block. But as you can see right now, it's a poor experience. Nothing changes on the front end. So how do we fix it? And let's use async and await and see how can we fix that. And the only change we will do to add async and await is just make this async, and here instead of a blocking sleep we have to use from async. So here we'll just add async standard library with the latest version. Depending on when you are watching this video, the version could change, but the name remains the same. And go to main, just change this and instead use sleep from async std and set the duration same, seconds 3, and await. That's the only change that we do. Literally everything else remains the same, our UI, handler, button, everything. And let's check for our hot reloading. It's done, and press the button, and as you can see, it displays the text for 3 seconds and goes away. Very seamless. And as you can see, the UI is free. I can do literally anything. I press the button, I can do anything, and the experience is very smooth. And what we did is use async and await. Now using async and await here is fine and it does the job for us, but we need to understand how the flow works. So when the button is clicked, the async block is processed sequentially as part of the handler, like the same lifecycle. It's tied to the handler's lifecycle. So the async block runs sequentially with the event handler. When we click, it sets to true, waits for this heavy task to process, be it any network call. Here we are just doing the simulation, and then updates the state before returning. The handler doesn't return immediately here, but still does the job for us. So yes, it's simpler, but can lead to limited concurrency control. For that reason, we have to go to the other solutions that we have, which is spawn, use future, and use coroutine. Now let's talk about future and spawn. So we'll be discussing about future and spawn together, the next two topics on our list. So future, as you might get from the word, is an asynchronous computation that represents a value that may become available later in the future. And it allows us to handle the task without blocking UI, enabling obviously responsiveness and concurrent operations for our application. Now we'll use future with spawn. So spawn is basically handling long running or resource intensive tasks that should not block the event handler. So as I discussed previously, right here our event handler works asynchronously, but the block inside, it has to wait for that block before returning. So for those cases, we'll be using spawn when we want to return immediately. And where else should we use spawn? When our task is not tied to the lifecycle of the component and we want to manage multiple asynchronous operations concurrently, and we require greater control over the lifecycle and error handling of background tasks. As you might suggest here, you don't have any control. Once the async operation starts, you have to be there till the operation finishes or the task that triggers it ends. Basically, you close the web application or you switch the page or close the app basically. But here In this case, you can control even while being in your application. Now let's try to understand these things with examples. So we'll be using the same code so you guys can understand it better. Now let's try to use spawn. So we'll just wrap this block in spawn and wrap spawn in the brackets and then the handler. Now as you can see, it's of fn event mouse data, and we expect this future to return unit type because that's what is expected. So we add a unit here, and that's literally what we have to do. And it now, when the button is clicked, doesn't block the handler returns immediately, and it basically spawns the future and make the changes. So let's see how does it work. Our hot reloading is ready. We open our UI, start processing. There you go. The same behavior as async and await, but here we can add multiple concurrent tasks and process it, and we have a better control here. Like we can have a separate error handling as well for this, but previously it was executed as part of the same life cycle as the handler. So as you can see, it works and it's pretty smooth. So that's for spawn. Now let's move to use future and use coroutine. But before we move, I highly recommend, if you guys haven't understood a single thing about each of these three things that we have talked so far, feel free to drop any comments or join me on Discord. And now let's move to use future and use coroutine. Now let's talk about use future hook. So we use future when we want to perform asynchronous operations that are tied to the component lifecycle. Remember, when we were discussing spawn, I clearly mentioned that we should use spawn when we want to perform tasks that are not tied to the component lifecycle, for example, background tasks. But here we want to perform tasks that are like tied to the component lifecycle. Let's try to understand this with example. So we'll just get rid of this code and try to understand with a different example. So let's get on with it. Now, as we start coding, just remember the point that we discussed. Use future ties to the component lifecycle. So as soon as your component mounts, use future just triggers your future. So that's why I like scrap the old example where we were triggering a future on an event. Now here it should start as soon as the component mounts. So let's code this basic example. So let's say we have a counter, we initialize it with 0, and then we have a running use signal, we initialize it to true, and then we have use future and move async, and here we have an infinite loop which checks if running, then it increments the count and sleep for 1 second. So this is pretty basic feature that we have. And now RSX, so let's add a div, and here we style it to color white, and then we display the count. So let's say counter and count, and then we have button, and on click we move and discard the event, and let's say this button toggles the running state. So basically toggle, it sets true to false and false to true. So start stop can be a good name for this. Similarly, we have another button, so let's copy this, and another button is reset. So we'll just do counter and set to 0, and we'll name this as reset. So pretty basic till now, and let's see how it works when the UI loads. As soon as the UI load, it will mount and the future will basically start. So go to the embedded browser that we have. Okay, as you can see, as soon as I just went on the page, the future is already running and counter basically is already up and running. Now, as you can see, it's changing to our user UI. It's tied to the component lifecycle. If I press stop, running toggle, and it changes from true to false and stops. Again press and it basically starts again. Similarly, if I reset, it goes to 0 and it starts from 0. So basically we are controlling the UI and using this use future. Now similarly, let's try to control this future as well. We could do the same by just adding let mutable f, I would name this, and this basically gives us this use future, and we have this button, and on click what we do is we just do f dot cancel. We just cancel the future and let's see what happens. So let's hot reload. It's done. We have 3 buttons now. The counter is going and we stop, we toggle it. This is basically just changing the state. We again press it and it starts counting ahead. We reset, it goes to 1. But watch out, what happens when we cancel? It stops there. I start again, nothing happened. I reset, nothing happened, because we literally cancel our future as well. So using use future, we get greater control. As you can see, we can cancel our future, we can pause, we can there is restart, so we can restart, we can resume. So there are lots of different operations that we can do and perform on this use future. Now, as you can see from use future, we could perform the operation, we could basically change something in the state, but we cannot return the output, and based on that we cannot re-render or change the UI. But that is possible with another hook, which is use resource, which is kind of a wrapper over use future, but it just has additional functionality, which is it can return you the value. So let's say when my component mount, I want to call an API, get the response, and based on that I want to display the response. So let's see how could we achieve that. So let's use resource. So let's just quickly change this, and let's say we have a use resource instead. Let's move all this, and here we have async move, and you can call any API here, but I just want to stick purely to the concepts of async programming here. And so let's say this is simulation to an API call, and this displays me hello world, the output I get from the API. And here what we'll do is match and future dot read unchecked. So some data we get, we'll just use RSX, and we'll literally go ahead and display that data. So P, and style as I would say color white, and then our data, so we'll just display data, and we have a button on click. We can re-trigger this as well. So as I mentioned, we could restart or re-trigger this as well. So let's cover restart here, and we'll just say restart. And similarly, if that's not the case and we get anything else, then we want to display an RSX saying load awaiting. So as you can see, it's pretty basic. It's similar to use future, but it could return the value to us, unlike use future. And we don't need it mutable. We don't need these actually. So pretty basic. Now let's test this. So back to our embedded browser, go to localhost 8080. As you can see, as soon as I come here, it shows me loading, and after 3 seconds it basically changes our UI. So re-renders the UI. As I mentioned in the start, it's tied to the component lifecycle, again repeating so you guys can understand, grasp these concepts. And as you can see, once the UI re-renders, it shows me hello world and restart. I press restart and it basically fetches the same value. But if we would have like different value, then it would fetch the different value for you and show you. But here, since it refetches the same value, so we go here, it ties to the component lifecycle, start as soon as the component start and sends you. So this is another great example of using use resource, which is, as I mentioned, a wrapper over use future. Now, after that, let's discuss use coroutine, which is a bit more complex, but again, I'll ensure you guys I'll make it fun. Now let's talk about coroutine. So coroutine is basically future which execute a long-running task, for example, WebSockets or uh, like polling or even background timers or periodic actions. Such tasks where we need communication continuously with your UI. So user types something, you send it to the backend, and then you receive the response, you display to the user. So let's see how can we enable that communication using coroutine. Again, one of the most important concepts for async programming. So let's get started. So let's start. Let's say we have an enum action, and the first action is idle, send message, close chat. Let's say these are some actions that we have for our example, and then we'll impl display for this action, so we could print all of these. So we have to overwrite, and here we will core fmt result and match self, and here we will add the patrons, and in case if it is idle, then idle. Similarly, if it is send message, then sending message, let's say. Similarly, if it is close chat, then closing conversation. Now this is not something related to async, but related to the scenario that we'll be discussing here. Now here we'll add a state or signal action, use signal, idle. Actually, let's name it current action, and let's say we use coroutine and mutable rx, so it basically establish a channel, and we have our unbounded receiver action, so we can literally send data to our future. So once we have this, and here we'll just say async and move. So right here we'll just say while let some message on our channel, so rx next, and we have to import next, and from our async std, and wait. So if we get some message, we'll try to match the message and add remaining patrons. So in case the action is, let's say, idle, then we want to set the current action to idle. Similarly, if it is send message, then current action to send message, and current action to close. Now, what could be another use case that we can perform here is when we receive send message, we send the message to our backend using WebSockets. When we receive close chat, we send the close signal, close WebSocket signal. So I'm just, setting the state here, but again, we can replace it with sending the actual message to our backend. Now let's quickly add our UI, and when I'll give you a demo of this, then you guys can understand how useful is this use coroutine that we have for async programming. So we have a P style color white, and then we'll just show the current action here. Similarly, we have button, so on click, move and discard the event, and here we'll just do is x dot, or let's use our coroutine, so let's say x as the, and here we'll just do x dot send, and we'll send, if this button is pressed, then we want to send the start message, so whatever message you want to send, but right now I don't want to send anything, so I just send start as it is, which is my send message. Sorry. And then once we have on click, we'll name this button as send, and similarly I'll just copy this, and if in the chat someone press close chat, there is a close button. So that's how simple our app is, and in this use case I'm just sending this, but you can literally send your text. So let's say you want to send the text, then you can pass the text whatever you want to send and send that text. So what we can do is, let's say a string, and we pass, we expect the message here, and then let's use format, and we format our message, and send it to our server, but right now we just write it. So here in the send message, we expect a message, and we'll set that message, and here while send, we want to send the message, so hello from UI. Pretty basic. Now let's run this and try to understand. Actually, here instead of format, we could directly use the write macro, and it does the same job. So run, and let's go to localhost 8080. So we have the idle as the initial state, which is right there, and then we have two buttons, send and close. Press send, sending message hello from UI. The message that we sent is printed. Similarly, if we want to close, close. And you guys can see how seamless it is. I mean, imagine if we want to build a chat application on top of this, how seamless is this async communication? Like, you can literally have a await here as well if you want. Let's add it. So back to our code, and Here we will add a thread. Oh, sorry, we'll use this. So let's add an async operation here as well. So we wrap this, and here let's say we call our backend and we say that sleep, just to simulate our backend call from seconds for 3 seconds, await it, and then after 3 seconds we set the current action set, and there we can set to the idle state as well. So back to our code. Okay, it's initially idle, sending the message hello from UI. 3 seconds later it turns to idle. So basically you can simulate this with a backend call, similarly for close. So that's how simple it is to work with async operations in Rust. So that's it for this video, guys. I hope you guys understand and really grasp all of these concepts. If you have any questions, feel free to drop in the comments. I'll be happy to help, and I'll catch you guys in the next video. Thank you.